will notice something that sets this example apart from the ones that we previously looked at. There's an absolute value expression on both sides of the equation. So if you remember kind of the progression that we've gone through so far, we started out single absolute value. It just had some constants and stuff around it. We got it by itself, split it into two cases, got the two answers. Then we looked at some cases where, okay, we've got variables on both sides of the equation. Now, let's look at some cases where we have absolute value on both sides of the equation. Now, here's the deal with these problems. The ones that I'm going to give you, and I think really any of them that you will see, notice this absolute value expression is exactly the same on both sides of the equation. And that's the key to being able to handle this without technology. Since they are exactly the same, just think about it like this whole expression is a variable x. Okay, so if you had 2x on this side and you had the x on that side, what do? You want to get the variable on one side of the equation. So the same thing here, we want to get that absolute value expression on one side of the equation. So in this case, always subtract the smaller one or add the negative one, whichever case it may be. So we have removed it from the right side here because we had it and we took it away. On the left side, we had two of those absolute value expressions and we took one of them away. So now we only have one of these absolute value of 9 minus 3n expressions. Okay, we had two, we took away one, so we just have one. And then now we're just back into the same scenario that we were in when we first introduced this concept. You got to get the absolute value by itself. So then we've got to move the 4. Now it is by itself, so we split it into the two cases. First case, just drop the absolute value, keep everything the same thing. Second case, drop the absolute value. Yes, I'm sorry. Yes, but we took one of them away. We subtracted one, so 2 minus 1 is 1. Yeah. All right, let's see here. So we subtract the 9. So negative 3n is equal to 0. Divide by negative 3. 0 divided by anything is still 0. Subtract the 9. Negative 3n is equal to negative 18. Divide by negative 3. So it looks like 6. There's our other answer. Always, always, always want to check them. Obviously, we've got a little bit more going on in this equation here. So just a little bit extra to type in. Now, honestly, plugging in 0, probably should just do that without the calculator, but that's okay. 13 plus absolute value. Never hurts to be thorough, right? When you plug in 0, you get 22 for both sides, so 0 checks out. And I'm going to cheat a little bit. Second enter, replace the 0 with the 6. We get 22 again. Replace the 0 with the 6. We get 22. So 6 checks out as well. So 2 solutions are confirmed in that case. Okay, let's do another one because I get it. These are kind of weird. We've got coefficients in front of our absolute values and we're combining and it's a little weird. So we have 2 absolute value of 4n minus 1 plus 1 is equal to 21 minus 2 times the absolute value of 4n minus 1. So again, key is those absolute value expressions have to be exactly the same. If they're not exactly the same, we can't put them together. But I'm not going to ask you to do it if they're not exactly the same. Okay? That's just a technology. You use the technology in that case. Okay, so for this one, since the right side has a negative coefficient in front of it, Let's add the two square roots of, or not square roots. Whew, where did the square root come from? Absolute value of 4n minus 1. So it's gone over here because we had negative 2 plus 2. That's 0. We had 2, and then we added 2 more, so now we have 4 of these absolute value expressions on the left side. And the right side, we've got the 21 left. Again, we're right back in that same boat where we started this lesson. Subtract 1. I want that absolute value by itself. Subtract 1. Divide by 4. Two cases. Keep everything the same. Drop the absolute value. Change the sign. 4n is equal to 6, so n is equal to 3 over 2. 4n is equal to negative 4, so n is equal to negative 1. I just didn't show the division in those. Probably our answers are okay, but let's check them just in case. Reminder of storing the fraction as x, just so you don't have to type it in so many times. So store 3 over 2 as x, and then I can just type in 2 absolute value for x minus 1. Close parentheses plus 1. That should be equal to 21 minus 2 times the absolute value for x minus 1. I get 11, so 3/2 checks out. Another perk to storing that as x is that I can just overwrite the x value, negative 1 stored as x, and then I can do second enter. There's the right side of my equation. Second enter. Do it again. There's the left side of my equation. I don't know. You might think that it's easier to just type it in again, and that's fine. Just showing you some shortcuts. We get 11 in both cases there as well. So negative 1 checks out as a solution. Okay. No extraneous solutions here, but there could be. There could be extraneous solutions. We just didn't run into any in the 2 examples that I'm showing you here.